Hello, everyone. I just realized I was muted. Welcome to Global Hack Week. I'm super excited to see y'all in the chat and see all the hackers super excited for Games Week. Today, we'll be learning about how to make a tic-tac-toe AI game. So essentially, like the tic-tac-toe AI will be unbeatable by the end of this game. But first, we'll kind of dive into the mechanics of making just like normal tic-tac-toe using Python and a little bit about the Minimax algorithm. Awesome. Looks like we have a lot of people in chat. I love to see it. Before we dive into a little bit more of a deeper explanation of what we'll be doing today, let me introduce myself. My name is Gabriella. I'm a coach here at Major League Hacking. But outside of that, I'm a tic-tac-toe and machine learning enthusiast, and I'm currently reading a book called Carmageddon by Daniel Nels. Pretty interesting stuff about walkable cities and car-dependent infrastructure. Also, if you haven't already, make sure you sign in and register your attendance to this particular event. I'll leave the link up there on the screen for a little bit. And if anyone has any questions so far about Global Hack Week or this workshop, feel free to drop them in the chat while I give you all a minute to register. All right. Hopefully that was enough time for you to register your attendance for this event. But if not, I'll be sharing it at the end again, and it's in the chat. And here's a bit of a brief agenda. Like throughout the course of this workshop, we'll be doing 3 different things. The first different thing we're going to do is kind of like an introduction to tic-tac-toe before we dive into making just like a basic tic-tac-toe game. It'll be text-based, and each user will manually input their information. So we'll have the X player like input their move, and then the O player. So just kind of like a basic tic-tac-toe Python game, no machine learning involved in the first one. And then we'll come back to the slides, and I'll give you a little bit of an explanation of the Minimax algorithm and a little bit more about like the math and the trees behind that. And then we'll implement the Minimax algorithm into our tic-tac-toe board. So we make kind of a computer that y'all can play against. And I have not beat, I guess I beat the Minimax algorithm in the tic-tac-toe game about once in all my time testing it. So it's pretty good at what it does. And at the end, we'll play a little bit of tic-tac-toe together. Awesome. I hope that sounds cool to y'all. So if you're unfamiliar, these are kind of like the basic rules of tic-tac-toe. The game needs 2 players. It's the most you can play with is two players. I guess you could play with more if you were separated onto 2 teams, but I haven't seen that too regularly. One player is X, the other is O. You can see a couple example boards on the right here. To win, one player needs to get 3 in a row. So you can get it diagonally, horizontally, vertically, at different points on the board. Tic-tac-toe boards are 3 by 3, 9 different squares total. So you'll be making a maximum of 9 moves combined throughout the entire game. And a cat scratch, also known as a tie, is when the board is completely full and no one player has completed a row of 3 in 1. As you can see up here in the top right corner, we have a cat scratch where one player was not able to get 3 in a row for any particular one. And then a few variety of situations where the X player or the O player was the winner. All right, so that's kind of the basics of tic-tac-toe. Now we're going to kind of get into coding up this game in Python. We'll be using Python for our language. And I'll be sharing my screen. All right, so this is kind of like our starter code for tic-tac-toe. This is in Jupyter Notebooks in GitHub code spaces. So first, I'm making a function that will define a specific board and a specific player. For tic-tac-toe, I'll have a function to display the tic-tac-toe board, see if a player has won or not before we end up actually playing it. this is kind of the basics we'll be putting our tic-tac-toe like algorithm into after I explain Minimax. You're more than welcome to code alongside me if you'd like to. I'll be sharing all of the code afterwards, though, in a GitHub gist. The link is not currently on the slides, but I will update it on the slides pretty shortly after the stream, so you're able to access the code after the fact. What I'm using to code right now is VS Code on the browser. So I'm using GitHub code spaces for a repository I already made, and it's in the browser just to make sharing a little bit easier. And as far as the slides, I have a bit.ly link to share this with y'all after the fact. So there'll be a bit.ly link at the very end of my slides. All right. So I'm going to get started. So the first thing we need to do is just kind of like make a board. And I'm going to be doing that using just kind of like a basic class structure in Python. Pretty, I guess, like simple class. If you're familiar, and I'll do this by creating a board. And I'm going to create a board that consists of a list. And I want the list to consist of a bunch of different spaces. So we have kind of those empty spaces for the X's and O's to go in. I don't want them to have anything like inside of those blank spaces when we get started. So I'm just going to have blank space for I in range 9. So this is essentially going to make like an entire list of just a bunch of blank spaces for like the entirety of like zero, like up to including 9. So we'll get that like basic tic-tac-toe board structure. And then after that, what I'm going to do is create kind of like the default current player. And that's going to be X. And that will switch on and off before we go like hopping from one player to the next. So I'm going to declare the current player as equal to X. So here we are creating our current board in the player. And then after that, I want to have a function that will display the board before the user is playing. Just because like when you're like wanting to play tic-tac-toe, you of course like want to see what you're playing with, and like makes the game like more intuitive and functional. And this will just be kind of like a basic function. I'm just going to say print triple T board. Triple T stands for tic-tac-toe. It's just kind of like a basic function. It doesn't really need any particular input outside of itself. So we're calling like this current class just so everything's kind of like in the same structure and like easy to access. And here I'm fixing the indent for this tic-tac-toe board function. And then what I'm going to do is have a for loop that's going to go through each row of the tic-tac-toe board. And it's going to print them together because as you can see here, we have like a list of just like 9 different blank spaces, but I want those to be coming together in like a cohesive manner. Kind of like I showed y'all earlier, the tic-tac-toe board has like 3 squares in each section. So we're going to want to join those together in a cohesive way that makes sense. So I'm going to do for row. So for each particular row in the board, I wanted to print out the different characters joined together. So I'm going to put in a little bit right here so it's able to kind of recognize like self.board as a row for each 3 indices. So we'll do self.board. This is accessing the board, and then we want to access it in increments of 3 at the index. So what I'm going to do is I'm going to do I multiplied by 3, not 2, oops. And then I want to go from that and splice it to I plus 1 multiplied by 3. So it's able to find the entire increment of like that row, if that makes sense. So this is able to splice from the beginning of a row to the end of a row. So it's finding this like 3 characters kind of like in increments of 3 to make an entire board. And then after that, I'm just going to have it be for I in range 3. And then what I'm going to want to do is print them out all together after that, all joined. So I will have this as kind of like my join character. This will make it easier to see, kind of like a box. It won't be exactly squares for the tic-tac-toe board, but it'll be a little bit easier to separate all 3 of them. And also now looking at my stream, I can kind of see that my code is a little bit small. So I'm going to zoom in a little bit so y'all are able to see the code a little bit better. It looks better in StreamYard. If you need it to be any larger, just let me know. And this code will be accessible at the end, so don't worry about that. So what I want to have it join, I want to have one of these before and after this particular item. And then I'm going to want to join that with the particular row. I want a little bit of a space here too, just so it's not all super cramped together and a little bit more readable as a tic-tac-toe board. I think that kind of marks everything that I am looking for. And if like the formatting isn't perfect, we can always go back and change it. But I think this looks like a pretty good tic-tac-toe board. Everything's joining together pretty well, in my opinion. So yeah, I do think that, yeah, okay. I'm just kind of looking at the spacing and seeing like how well it will work. So we have completed this function. I'm going to run this particular code block and see if we're getting any errors at this point. Doesn't look like we have any errors right now. Now we can move on to the next function to check if the player has won or not. So this we're going to call check winner. We're also just going to have the class we created earlier that's just storing the different characters of the tic-tac-toe board as well as the current player. We'll be able to change the current player whenever players are actually making moves, but we don't need to focus on that right now. So next thing we're going to do is create like the indices of potential winners. So I'm going to copy in all of the indices of potential winners and kind of walk you through how I came about that. This is from when I was walking through this code earlier when I was creating this workshop. So here we have a list that holds a bunch of pairs, or not pairs, triplets essentially of all the potential winners. So the 0, 1, and 2 would be at an index of 0, 1, and 2. So that would go across like horizontally on the top row. 3, 4, 5 is the same thing horizontally, but the middle row. 6, 7, 8 is the indices of a horizontal win at the bottom row. 3, 6, or 0, 3, and 6 would be diagonal starting from the top left square, the middle square, and then the bottom right square to create a win. 1, 4, and 7 is a win that is vertical and goes from like the top down vertically in like the middle of the grid. And then the winner of 2, 5, 8 is similar, but to like the right vertical grid. 0, 4, and 8 is also similar in how it like is formatted, as well as 2, 4, and 6. So it's kind of following similar patterns, but just finding those indices of all the winners together. And for these, I'm just going to have them equal to winners. And then after that, I need to actually check if the different items that we have kind of like selected as plays are winners. Some of this logic is coming a little bit before we're programming how you make plays, but just kind of follow along and I will explain it as we kind of get farther along into this function. So after that, we want to kind of iterate through all of the items within this winners list. And we also want to like kind of cross-reference it with what we're looking for. So I'm going to say for win in winners. And then after that, I'm going to check and see if anything on our board, so like that's being contained in our class up here, is equal to the different items in this winners list. So there'll be a pretty long if statement because there'll be a bunch of different things we need to check for. So essentially, we want to see if our winners is equal to different items on the self.board. So if win of 0 is equal to self.board at the index of win 1, and it's also equal to self.board at the index of win 2, then we might have a winner. In addition, it also needs to be not like an empty space because we don't want it to still be equal to kind of that default variable we defined earlier of like the blank items. And in that particular instance, what we're going to do is we're going to print our board in this case, and then we'll kind of like declare like there's like a winner, which we'll do by just like returning true. So I'm going to say return true for now, and we also want to print our board. All right. And then if it's not true, we're not finding all these to be equal, I'm just going to return false. I'm going to run this again to make sure there's no errors. We are getting an error. Invalid syntax on this particular. Oh, I see. I put the exclamation point after the equal sign. That would cause some errors. Perfect. Okay. So we see everything is returning properly. And what this is essentially is doing is it's looping through the entirety of this winners list, and it's double checking to see if this particular win, so like if the first item is equal to the item that we're seeing at the index of this particular item. So if we have win at index 1, that's going to be 1 right here. So if that's also equal to the item that's on like self board at that particular index, we're going to see that it's matching up, and these will kind of continue to grow as the index grows throughout the loop as well. Oh, it looks like a few of you pointed out the exclamation point after the equal sign. Thank you for catching that. I'm kind of going back and forth between comments as well as my code. So if you catch anything before I do, drop it in the chat, and thanks for any of those you might catch in advance. Awesome. So now we've kind of gone through this. We've checked a winner. Next thing we want to do is see if there are like if this happens and we're getting returned false, even if the entire board is full, we don't want to keep asking our players for their plays. So we need to check, is the board full and there aren't any winners? Because in that case, we just need to end it and declare it a cat scratch. So I'm going to declare this as the function cat scratch. If I can spell. And I'm also going to have it be taking in self, just because it needs the current board as well as the current player. And what we're going to do to see if like there's anything, it's pretty simple. Honestly, we're just going to have it return whether or not we're finding any empty items still in this list right here. So we're going to return blank, not in, I think it's just going to be self dot board. I might just be bored with this syntax, but we can run it. It doesn't look like we're getting any errors. Yes, so this is going to be accessing self.board, and what it's going to be doing is essentially if it's finding any empty indexes in this list, it's going to return true, and otherwise it's going to return false if it is finding those specific ones. So if it returns false, there are still these items. It means there's still more plays to be made. But if it's returning true, that there are no more blank spaces, then we'll know that there's a cat scratch. We don't necessarily need to see if there are no winners, because if this function check winner is returning false, and then this returns true, then we're seeing that there's a cat scratch because like of the logic behind there's no reason to add more if else statements into our cat scratch function, because we'll already be having the check winner function run after each play. All right. So now in order to actually play the game, we're gonna have to like have the players make moves, include some error handling in order to make sure that like they're not entering like the wrong numbers, that they're like within our array, that we're going to actually be calling all these functions we declared earlier. So I'm just going to have it be called def game. We're also going to be using self. And then after that, I'm also going to have it take in one other item. So we're going to have the particular position. And this position is the item that will be the user is inputting as their particular move, if that makes sense. So the first thing we want to check is to make sure that the particular index that the user is inputting is not already taken. So we're going to first check if self.board at position does not equal blank, then we can kind of proceed with everything. I'll put XYZ here for some logic we're going to include later. But if not, we're going to need to return something to see if like the user can kind of like make a new move essentially. So what I'm going to say is I'm going to print out that was an invalid move. Please input a position that hasn't been taken yet. I need to have those quotes being displayed correctly. And I'm also just going to have a return false statement. So it kind of like ends this. We could also maybe do a break in this particular instance, but I think return false works well for our purposes. All right, so now we need to go through and like see what happens if like they actually made a valid move, making those plays and making sure that everything is kind of checking out. So the first thing we're going to do is essentially assign the particular index. So self.board at position is equal to self, if I can, dot player, current player. So this will be assigning either X or O to this particular position. And as I make moves, their player will be updated in the board if it's not already taken. And then after that, we want to check and see if there's a winner. If they made a move right then that it like makes them win. If you're playing in real life, then your game is going to be over. So you want the game to end right then rather than going through any other logic. So next thing we're going to do is we're going to run the check winner. We're going to do self.board or no, self dot check winner. And then after that, if that's the case, then it's just going to return the winner, and we're also going to return true because this is like, it's been a valid move. So we'll have return true after we first print player board underscore current player. Oh, we need to have self, not board. Won this round. Nice job. So if that's the case, then we'll just have a return true. But if not, we're going to also check if maybe there's no winner, maybe it's a draw. So we'll do self.cat scratch. And like, if that's the case, we'll just print out there are no winners. Oh no, a cat scratch. There are no winners, and we'll also return true because it's a valid move. I think that that's all we need for our particular game. I'm going to play it again or run the code again, and we'll see if we're getting any bugs. Awesome. It looks like we're not getting any bugs. So let me run through and actually call this function so we can see how it's working. I'll be calling the function down here where I'll be actually instantiating that class and creating more error handling on the actual game side. So the only thing I'll need to do is game is equal to tic-tac-toe. And I do think I'm going to change this function to be not game, but I guess play, just because I'm naming the instance of that class to be game. Then after we do that, I'm just going to create a single loop. And while play is true, it's going to continue playing those games. And if something is false, it's going to have you essentially make a new move. So here we have while true. So while true, we're going to be playing games. So game, print the board. So after it's printing the board, it's going to ask the user for some input. And we'll do this by saying position is equal to user input. And we need to ask this in a specific way because we need to make sure that the users know when they're being X and when they're being O. So we'll be doing this by saying player dot it's going to be self. What did I name it? No, it's going to be game dot current player because of the class I named it. It's your turn to make a move. Please select position between 0 and 8. Here I need to fix the quotation marks. And then after I essentially input that information, I'm going to have the gameplay over and over. So if game.play at position So essentially, while that's running true, we're going to have that run. And if not, we're going to break this so that the function continues. So let's see how this is working. All right, it says player X, it's your turn to make a move. Please select a position between 0 and 8. I'm going to say 0. Okay. Has no attribute play. Oh, it's because I did not rerun my function after I renamed the I did not rerun the block of code before I rerun my function. 0. List indices must be integers or slices, not string. All right. So here I need to change the logic a little bit. So it's checking to make sure that it's not an empty string, but that it still is kind of like following that particular logic structure. So let's take a look back at it. Okay, I think I see what I did incorrectly. So rather than have it be checking if win of 0 is equal to self.board at win of 1 and win of 2, I should have been doing self.board for all 3. This is actually checking all of these equally. That's not going to fix this particular error. That's another error I'm seeing now that I'm like looking at the code a little bit more in depth. And then after that, I'm going to look a little bit more deeply and see what is going on with my code to make that. Let's see what the error is. List indices must be string integers or slices, not string. Maybe it was just this that was the issue and not this. I'll try it again and see. Right, that's working. Here we go. 0. It broke. Okay, same thing. List indices. Okay, I am thinking that that's the issue. So if self.board at index 1 of 0 is equal to self.board at 1 of 1 is equal to self.board at index 1 of 2, it's not equal to empty string. I'm going to want to run game print board. It's angry at this because I am like defining game out here, but it shouldn't actually make a difference. All right. Is maybe the space not the exactly the same? Running maybe it's this. That's a little odd. But maybe that's what it is. Oh, I see what it is. Okay. It's because my winners are string rather than. Okay, that makes sense. Okay. Oh, yeah, okay. I'm seeing what y'all are saying. I'm not converting my position to an integer down here from the user input. Okay. Okay. It's telling me that was an invalid move. I need to input a position that has not been taken yet. So let's go up to here and see Okay, this is not far enough out to catch a cat scratch. But no, because that's just if it's empty. Okay, let me talk through this real quick. If the position is not empty, okay, we're going to put the position and make it into the current player. If we check the winner and that like it's returning true as there is a winner, we need to return player is the winner. That all looks good. We're returning true. I think we maybe need this else statement to be a little bit farther in. Oh no, I see what I'm doing. There is no else statement here to catch if there's no winner, no cat scratch, and the board is also, the position's also being like filled. So I'm seeing I did not add enough handling here. So that's a functionality that I need to add in. So in this else statement, what I'm going to need to do is I need to switch between players, because if we're not switching between players, it's automatically going to go to this else statement afterwards, because it's going to like be overriding a move, but we don't have any way to make a new move if we're not changing between players. So the way I'm going to do that is just going to be adjusting the current player pretty easily. So we'll create self.currentPlayer, and we're just going to kind of check and see like what it is. So if self.currentPlayer is equal to X, we're just going to have self.currentPlayer be equal to O, and then else it'll just be, oh, I ran it instead of typing through everything. That's my bad. I hit shift. Self.currentPlayer is going to be equal to X. This needs a double equal sign. Okay, let's run this again. My bad, y'all. I was rushing through it a little bit too quickly. This, I think, should fix it. We're going to do 0. That was an invalid move. What's going on? Run again. Run my code again. 0. All right. All right, so it's saying there's an invalid move. Invalid literal for int. Okay. And it's on this line. Oh, I converted it too quickly, or too late. So we're going to do it right here as soon as it gets the input rather than later. And then that should fix it. But I also did need to change the players as well. So it was good that I fixed that up above. So we'll have 0. We can, okay, escape. I'm going to run this. Run this. I'm just going to have it be 1. Invalid move again. Okay, let's go through and see this one more time. So if the position is not empty, we're adding in the current player to the position on the board. Then we're going to check if the winner is there. And if the winner is there, winner returns true. Cat scratch is there. So if the position is not empty, am I maybe just not calling the print board function? I think that might be the issue. So Yes, okay. Oh, no. I see what I'm doing. Yes, okay. We also need to end this so that we're switching out this play, kind of closing out this play to the, like from player X to player O. So this will essentially break this particular play. So it's ending. We don't need to go on to the next play. Okay. There we go. Play 0. Again. Please input a position that hasn't been taken yet. All right, escape. What on earth is going wrong? Not, okay. I think not quite indexed enough. Apologies, y'all. I'm a little confused what I'm doing. If self.board is not empty, change the position to the current player, and then check to make sure there is a winner. If there's a winner, return true. And if there's no winner, we're going to say it's a cat scratch. We're also going to return true. And if not, we're going to make the current player into the opposite of what else they are. And we're also going to return false. And then otherwise, it's going to be an invalid move. So self.board. Okay, this is all contained within this. Okay, nice. That's how it should be. Self.check winner, player wins. Nice job, return true. That's all good. Elif, we're going to check if it's a cat scratch, printing out, returning true, and else. I think maybe I'm just gonna combine this into a simpler if else flow. I don't think like that should be causing any issues, but I think it might simplify things a little bit so code is slightly more readable. So self dot current player is equal to X if else gonna uncomplicate this, get rid of all this, and I also am gonna double check that I am declaring all my classes correctly. Okay. Yep, I'm seeing what it is. That should have been equal to rather than not equal to, because then it's immediately sending all of the traffic to the else statement when the board is empty, which allows for no plays. Good catch. All right, so it's always the little things, like a simple character. All right, we're gonna play 0. Okay. It's not switching quite yet. So I'm just gonna say 1, Okay, 2. So it's not switching our players. So I'm going to go here and see what is going wrong here. I think it's because I simplified this, to be honest. So self.current player. Oh, again, simple character. It needs to be changed around slightly. So if current players equal to X, otherwise we need to make self.current player equal to X. Again, just wasn't properly switching. It was automatically just staying X. And then print that. So yeah, okay. And then print this again. 0. Okay, now we're switching players again. I just put an X where I was supposed to put an O. Reverse the 2. And then now we're playing. You can see here that it's printing out the board, as well as we need to have player O take a turn as well. So player O is going to play position 1. So that's going to be middle top row. Here we can see there's an O. It looks a little bit odd, so I'll switch that in a second. But now it's player X. I'm going to say position 3, try to go vertically. Player O is not paying attention, so they choose play 4. And then X will go into play 7. So as we can see here, player O has another turn. They're going to go with play 8. And then player X is going to decide, I want to win. So they're going to go for, let's see, 0 plus 3. You're going to go for play 6. And player O is going to go for 7. All right. So it's not quite breaking yet whenever there is a winner, because here we have a winner right here. So I'm curious what I'm doing incorrectly. We'll go back up and check the errors real quick and make sure that that's all properly moving. But the main functions of the tic-tac-toe board are working. It's just not the winner validation yet that's working. I'm just going to go to play this until it breaks, essentially. We have a better insight into what's going wrong. All right, play 2. Okay, there was an invalid move. That's working. Play 3. Okay, view a scrollable element. All right, player X. I'm going to say 2. Tell me it's an invalid move. Try again for, we'll go to play 5. Okay, there are no winners. I'm going to have it print out the board again when there is a cat, scratch, or a win, just so we can see the final board. So self, print the board. I'm going to save this again, and then we'll see if it's honestly just because it's a truncated board that the win wasn't going all the way. All right, we'll do play once more. Okay, we'll do 1. Player O, I'm going to play 0. Player X, I'm going to play 4. Player O, I'm going to play 8. And then player X, I'm going to play 7. Okay. So it's not finishing when there's a winner. So let's see if it just needs one more move. It might be something with the if-else statements that's a little messed up. We'll go with play 2. All right, no, it's still, there's an X one here. Play escape. Okay. So if self.check winner, let's see. We're playing the game, and in play, it's just going to be an if statement. Okay, so we're not checking there were any wins before this. Okay. This needs to be a little bit higher up. All right. So if self.check winner, there's probably something in here to be honest. For win and winners, if self.board at index win 0 is equal to self.board at index win 1, index win 2 is not equal to a blank space. Let me ensure the blank spaces are equal, which I'm like 99% sure they are. Yeah, that looks, yeah, the same to me, so that's not what it is. Oh, that may be what it is. We're gonna have it print true, and then if not, we're gonna have it, oh no, I see what it is. This needs to be not within an if statement. This needs to be just out here. And then we'll have the return true just underneath printing out the game board. So this is essentially going to be like not putting that within an else statement so that it's returning after the fact that this is just not true rather than an else statement. We'll run this once more. I think that should fix our problem. So I'm going to do play index 0. Play index 1. I'm not printing these quickly enough. I'm just going to have it print after the position changes. So it's easier to kind of see the flow of this game. 0. So we have X is being printed twice. I'll ignore that for now. We can fix that bug later. Index 8 for player 2. And then we'll do 1 for player X. Player 8 for player 0 we'll do index 7. And then I'm going to do index 2 for this. Okay. And then it's properly ending. It is just printing an odd number of times. Because we're almost at the halfway point, I'm going to ignore that bug for right now. And we can get into the Minimax algorithm in a second, just because like that's kind of like a small syntactical fix for what we're trying to achieve overall. But kind of as a recap of the functionality of this board, and there's a few small errors that I ran into throughout the process because of little characters. This isn't essentially instantiating a class right here of Tic-Tac-Toe. And we're running just like a while true loop, and it's going to print the Tic-Tac-Toe board before it asks the user for a position. So here we have the initial board before it asks the user for one, and then we have this. It's printing out a second time before it asks the user because it's printing out after the current player. So I think I'm just going to comment this out, and that might resolve that issue, but we'll see that after I go through and play it in a second. This right here is declaring the position as the input from a user. It's asking player, and it's telling them if it's X or O. So if you're playing with a friend, you can pass the laptop back and forth. And it's telling them which specific positions to make a selection from, and it's converting that to an integer, so it's possible to actually access items at a particular index in our list. And then while gameplay at position is able to run, we are running it, and if not, we're going to break this particular item. So yes. All right, so I'm going to switch back to our slides, and I'm going to talk through a little bit of Minimax algorithm. Before we get back into the slides, I'm going to give y'all a brief intermission. You can grab a little bit of water, head to the bathroom real quick. I'll be back in about 2 minutes. So y'all grab some water, grab a snack, or head to the restroom for a little bit. But I'll be back to walk y'all through kind of like the Minimax algorithm part of this in just a few minutes. All right, y'all, I'm back. I hope you were able to grab some water, get a snack, take a little breather for a second. Now we're going to dive back into the slides. I'm going to tell you a little bit about the Minimax algorithm and kind of like the concepts behind it before we get started. Yeah, and where it says GitHub link here in the slides, I'll be updating with a GitHub gist with all of the code from today. So if you'd like to go back and kind of like check it out later, you'll be more than welcome to after the stream. So here's a little bit about Minimax algorithm, kind of like as a like short synopsis. Minimax algorithm is a recursive algorithm that you can use to find the best move that minimizes maximum possibility to lose. So essentially, this algorithm is finding the maximum possibility to lose in a particular move, and it's trying to minimize that by choosing essentially the opposite of it. There's also an inverse that's called maxi-min. It's used to maximize gains and wins. So if you're trying to kind of maximize the number of, I guess like the percentage your portfolio is going up the market, that's like a pretty easy example. You want to maximize the gains in your win. Maybe it's not the most risk averse, and like there's of course like a more risk is like the higher potential gain. But that, I guess, like inverse of this would be called maxi-min. Minimax is essentially just making sure we're not losing, which is how this algorithm allows for the Tic-Tac-Toe AI to be unbeatable, because it's finding the worst case synopses and the worst case moves to have you win, and it's avoiding those at all cost. That's just kind of like the general gist of how Minimax works. Minimax is used in a variety of games. It's used in statistics pretty often. It's used in philosophy as more kind of like a conceptual, like do like the least amount of evil kind of like philosophy, as well as in artificial intelligence, which is like how we'll be like simply using it today. There are, of course, many more advanced applications of Minimax algorithm, but those take much longer to implement. Today, we're applying it to Tic-Tac-Toe, which is a pretty simple two-person game, but you can apply it to more complex games, whether that be something like checkers, where it's a little bit more complex than Tic-Tac-Toe, or chess, where it's much more complex. There's a lot more rules, a lot more players, and a lot more specific moves that the algorithm will need to detect. This is essentially, this screenshot down here is the math behind Minimax algorithm. I won't bore you diving into the math of Minimax algorithm at all. Also, we're running a little bit short on time, so we'll need to head into coding out the Minimax algorithm and kind of implementing that with our Tic-Tac-Toe game. But this is the gist of Minimax algorithm. All right. And here is a little bit of a visualization of game tree nodes, and this is kind of like how visually Minimax as an algorithm works. So right here, this dark brown Tic-Tac-Toe board is the current state of the game tree. And this is where the Minimax algorithm is invoked. So this is the information that the algorithm is given. And essentially what they're going to do in this algorithm, they is essentially the AI. As you can see here, I've marked that the X player is the AI and 0 is the human who's playing against the computer. They're going to, the AI is going to find each potential move. So here we see there's 3 different squares that Minimax is able to put an X in. So they're going to put it in each of those different options. And then it's going to go through the different depth levels. So because there's only 2 items left, it's only going to have 3 depth levels. But if Minimax is invoked onto like a blank Tic-Tac-Toe, it's going to run through the entire board. So it's going to take a lot longer for a Minimax algorithm to run the earlier into a game it's invoked. So as you can see here, it puts an X here and it's not initially a winner. And here we're also putting an X where like after O plays, and we're seeing that still no one wins. That's minimizing the potential loss. So that's green because it's doing well. Here, we're seeing something similar. So this is like essentially like the leaf node, like where it's ending. Or I realized I just misread that Tic-Tac-Toe board. It's ending because O is winning diagonally. But we're going to see like where particularly O does win in just a few. Minimax is not a Python library. It's a particular algorithm that we'll be implementing, but there are libraries you can use in conjunction with it. Yeah, but as you can see here, it's going through and trying to minimize loss just by like finding every possible move and then choosing the one where they're least likely to lose as a player. So here we see X is initially played here, O down here. O is winning, so it doesn't want to go with this move, which is why this one is clear, because it's not a move that it wants to take. And here we have, if X is just played in the middle, X automatically wins, so the machine automatically wins. Here we have it's clear because both of these instances result in O winning, or O winning in this case, and then over here, we don't see the game ending until we have X here, but it takes the most amount of time. So this is the optimal solution because Minimax is invoked, and the likelihood of a loss is the least because in this case, if X were to be played here, there is the possibility of O winning with one move diagonally, or in the case that O doesn't play that, we could potentially win, but it's not minimizing the potential loss, if that makes sense. For the person who asked what if it's like stockfish, I'm not familiar with stockfish, so I can't answer that question. But yes, I think that's all the questions. And then for the person who asked to look at my code to check the inconsistencies between their code that they have locally and mine, that's what we'll be doing just in a second. And also, I'll be sharing my code like at the end in a GitHub guest, so you're able to see everything we went over in this stream. All right, so someone asked, can we just do a couple tests, as in if move is winning move, if block opponent winning move, so on and so forth. We are able to do that, but it gets very complex and memory heavy if we are doing like for the entire board, because there's so many possible like game sequences. When you implement Minimax algorithm, it goes a lot faster, essentially. Yes, and the person who asked, does it take the path with the least depth? It does. It takes the path with the least depth that has the highest likelihood of losing, because it allows for the least opportunity for loss. Like I said on this slide, it goes with the middle one because it wins in that instance, but also there is no possibility of losing, because in these cases, it doesn't necessarily lose immediately, but there is a possibility of losing, and it wants to minimize the possibility of losing in this particular case. So it's not optimizing for winning, it's just optimizing for the least likely to lose case, which will typically result in a win. But these both can result in the win. They're just not as likely to, because there's more of a possibility of a loss, where this is instant win, if that makes sense. All right. And it's pretty easy to follow the logic for Minimax algorithm in Tic-Tac-Toe because it's a more simple game. But if you're going to like kind of manually add in if like this particular position, then do move in something like checkers or chess or an even more complex game, it gets to be more unsustainable. I'm just using it on Tic-Tac-Toe as kind of like a basic example for y'all to follow. And it's easier to kind of code up all the pieces in the stream length of this afternoon. Yes, so here is a to-do list for an unbeatable Tic-Tac-Toe AI. I wouldn't say it's like always unbeatable, but I'd say like 99.9% of the time it's unbeatable. So there's a lot of different things we need to do. The first thing would be store the current state of the board in an array or list, which we already did. We made like a basic tic-tac-toe. And we need each of the empty cells to get stored as their index, which we already did. We also need to get an array list of empty cells, of like empty cell specific index. And then we need to see if a specific player has won the game, which we already did as well. Then we'll need to recursively invoke Minimax on each of the board's empty cells. So that will need to be done like more intensively on like the first go about, and then as each play is done, the Minimax like length to invoke it will become shorter. And then we'll need to return a score for every possible move for both player X and player 0. This is going to return a score so that algorithm is able to choose which one to take a little bit faster. It needs to choose the one with the shortest depth, kind of like we mentioned earlier. That also minimizes loss. And then out of all the return scores, we're going to choose the highest one that's guaranteed to minimize the human player's possibilities of winning the game, therefore maximizing our abilities to win. It's kind of like the inverse, but it's still like focusing on not letting the other player win and like minimizing our chances of loss. So yeah, we have about 4 different items we'll need to incorporate into our unbeatable tic-tac-toe AI. And I'll kind of like walk you through that whole process, but it'll be shared in a GitHub gist at the end of this. So don't worry if you're not able to completely follow everything in real time. So let's get back to coding. All right. So right after I got back from getting some more water, I tested out, just commenting out this print the tic-tac-toe board. If you remember earlier, we were having some issues where the tic-tac-toe board was printing too many times and it was getting to be a little bit confusing. So I fixed that. I'm going to run this code again and show you all it's working before we dive into the Minimax algorithm. So here, I'm going to make the move of 0. And here, player O is going to make a move of, let's say, 8. Here we can see everything is printing out. So we have player X at index 0 and player O at index 8. Player X is going to play at index 4. So now they're in the middle. Player O is going to play at index 7. And then player X is going to play at index 2. And player O is going to play at index 6. Again, it's not updating as fast. I don't know what happened in the 2 seconds since I brought this away. We're going to do 6 again. Okay, that was an invalid move. I think it's just not updating as frequently to the screen. Return a false statement in the check winners function should be outside the statement, so it checks for all possibilities. Let's see if you're onto something. In the check winners function, oh, I see what you mean. It's inside the for loop. That is right. We're going to escape this so it kills that. Run this again. And then here we go. 0, 8, 2, 7. I want to do 5, just mess with it a little bit. Then we'll do 1. 1 as well. Invalid move. Okay. Then we'll do. I'm going to do 3. And then O, we will do 6. Here we go. Player O wins. All right. Awesome. So we got the print statements worked out. The output gets a little bit truncated, which is why we're not seeing everything in real time towards the end. But as you can see, everything's printing out after the move has been made, which is cool. So now we're going to move on to invoking the Minimax algorithm inside of our tic-tac-toe. So I'm going to bring down a little bit of code we did earlier into our tic-tac-toe master function. It's going to function pretty similar to the last tic-tac-toe, but instead of having it switch between players, we're going to have it switch from the human to our algorithm. So the first thing I need to do is copy down the code that's creating the board and the player. So this we can just kind of bring down to here. So it's creating both the board and the current player. But rather than having it be X or O for the current player, I'm going to have it be human versus AI. And then I'm also going to declare which letter is AI and which letter is human. So for this particular instance, I think that AI should be X and human should be 0. Just for the sake of simplicity, that's like what our nodes had. So AI is going to be equal to X and human is going to be equal to O. O will play before X, but that doesn't really change the functionality of our game whatsoever. So it looks like we have all of these comments within inside of our init function. Okay, we've copied down creating the board and the player. We've created our list with empty slots. And we've created which letter is AI and which one is human. We have not done, I misinterpreted what I meant by this. So if you remember from our slides on the to-do list right here, I need an array list of the empty cells indexes. So this is essentially going to be a array list of each particular like each position on the board that does not have anything. So it makes it a little bit easier for our Minimax algorithm to run. So I need to make an array list, or in Python, just known as a list. Sometimes I get the syntax where it's a little bit messed up, moving between JavaScript and Python, of all the empty cells indexes. For right now, I'm just going to have that be kind of like an empty list, and we can update it as it goes through and like finds those different items that are empty. So I'm going to call this self.empties, and this will just be an empty list. So the next thing I need to do is add the current empty slots to the list. So I'm going to have a function that I need to bring out to the function level. And this one I think we can just call find empties, so it can find all of the empty slots, and it needs to have self, so it actually has access to the board. And what I'm going to need to do for this is just kind of like loop through the entirety of like the board and see anything that is empty and just kind of like add it to this array, this list. So I'm going to have self.empties be equal to a list. And inside of that list, what I'm going to do is I'm going to go through the entirety of like the length of this board. So I for I in range 9, and then we're going to do something else to kind of go through and see which particular items are actually empty. If I is not in X, O. So this is essentially going to see if the item is not in X or O in this item, it's going to go through and kind of added in the index. But here, rather than just having I, we need to have the actual board. So the first time this runs, it's going to return all of the indexes because the entire board will be empty. But as it goes around, it loops through and calls this function later on in the game. It's going to bring back essentially the specific ones, and it doesn't need to spend as much time because it's doing it in a relatively quick for loop. All right, so this has been done. Next thing I need to do is bring down the print board function. That'll be the same thing as what we did up here. So let's find the print board function, and I will put that right down here. I'm going to bring out the function so everything looks how it should be. Print the board. We're still taking in self. I don't think I named, everything is named the same as up above. So I think this is looking good. Let's go back to our to-do list and see what progress we're making. We need to check in one if a specific player has won the game. So we're printing out the current board, which gives us kind of like a visual cue of that, but we need to actually have the function that returns whether or not a player has like returned if a player has won the game. So that's what we're going to bring down now. Looks like Pharaoh is saying that there's some error on their side. I'm going to run the Tic-Tac-Toe master and see if there's errors. I'm not getting any errors on my side. If you are, don't worry. I'll be running through this entire thing and be sharing the code in GitHub Gist afterwards. So if there's something different between our code, you'll be able to find this solution towards the end, if not throughout the process. All right, so the next item on our to-do list is we need to bring down the check winner function. So I'm going to bring down our check winner function right here into our new class, which is class Tic-Tac-Toe master. Looks like the indentation is correct. The return false statement is at the correct level. There were some issues with that later. So first thing we need to do is check if a slot is in the empties list rather than just if it's an empty string. And so we'll do this by just kind of like altering this last part in the if statement. So initially we see just kind of like, is it equal to this particular item? So we'll like alter that in like more of like a advanced way. All right, so we'll need to, this has been done. So move on to altering our code to check if a slot is in an empties list rather than just an empty string. So and not in self.empties. All right, let's run this. Okay, we're not getting any errors. This I feel like needs to be more complex. Let me read through. So we have the winners, and we're going to be looking if the win, okay. Okay, I see what we'll need to be doing now. So rather than checking to see if it's an empty list there, we're going to need to alter it with the player so that we're able to go between the two players, if that makes a little bit more sense, because we'll have two players that are more distinct than just characters. So if, yes, okay. I will explain this just now. So essentially what I did is I edited the function right here so that it's including player in one of the inputs. And then here we have our typical kind of like winners list is going through the winners list and checking to make sure that these are all equal, like all of the items on the board are equal, but we're also making sure that all the characters are equal to the player so that we're printing off the right player rather than just X, because one character is equal to the artificial intelligence, the Minimax algorithm, and the other one is equal to the human player, just so we're able to print that off. And it's going to be like edit our return message a little bit as well. So then the next thing we'll need to be doing is bringing down our print function to be a little bit different for the winners. Yes, so I'll change the messages of that kind of like in the checking function in just a little bit. So I'm going to bring down the draw/cat scratch function. Cat scratch means the same thing as draw. So I'm going to bring down our cat scratch function. All right, that looks like it's all working properly. Okay, so now that we have our winner function as well as our cat scratch function, we're going to actually go into our Minimax algorithm, which is going to be the most complex part of our code for this particular function. So I'm going to define our Minimax algorithm, and it's going to take in this board as well as the player, so we know which player is actually playing. We're not going to run the Minimax algorithm for for the like human. We're just going to be running it for the AI. So that's the kind of like our first order of business. First thing we're going to do is we're going to check for the empty indexes. So we're going to be running find empties. That's the first order of business. After that, we're going to go through and see if there was any winners. So if self dot check winner is self dot human, we're going to return a particular score. So we're going to return a score that's either a 1, a -1, or a 0. So a -1 means the human is winning, which is we're losing, which is why it's -1. If the human is winning, it's going to return a score of 1. And if neither of them is winning, which is a cat scratch, is going to return a 0. So the Minimax algorithm is going to determine whether or not it should make a play by how large the number is. So 1 is the most optimal solution because the Minimax algorithm is winning. 0 is a second optimal solution because the human is still not winning. And if -1 is the answer, that's the least optimal solution because the human is winning in that instance. So what we're going to have it do when the human is winning is we're going to return a score. And we're going to have that be equal to -1. And then elif, we're going to have another kind of statement, and we're going to check the winner. And that is going to be equal to self.ai. We're going to return a score of 1. And if not, so if it's a cat scratch, we're going to return a score of 0. All right, so it looks like we have this done. I'm going to make this a little bit smaller together. And then we can be going on to the next part of our Minimax algorithm. So after we have gone through and checked the different winners, we're going to return a score. But then we need to kind of like make a space for all of our plays. So we'll do that like this. This is just going to be kind of a placeholder for all the different plays we're making throughout the process. And after that, we're going to begin diving into the gameplay. So the first thing we're going to do in this is just kind of like loop through our like empty board so we can find like the different node trees. So for index in self.empties, oh, I clicked shift instead of enter, my bad. So for each item in that empties array, we're going to create a specific set of play for this item. So that is just going to be equal to this, which will be kind of like holding our plays for this particular like position. And then we're going to adjust so that plays at a specific index, so at this index, is going to be equal to this. So this is essentially going to be assigning the particular item in our empties array into an item at this particular index of like that position, if that makes sense. All right, and then we're going to change the item at the index in the board to that specific player. So we're going to go to self.board at index, and it's going to be equal to player. All right, and then after that, we need to start doing some actual checking to make sure that we're properly running everything during this game, because this is kind of the basic plays. And if it's the AI, we need to be running a little bit more complex analysis using the Minimax algorithm, because it needs to be recursive in nature. So now if self.current player is equal to AI, then we're going to start running a few functions. So I think I can probably do this in a more intuitive way. There we go. Yes. So if player is equal to self.ai, we're going to have the result of our gameplay be equal to us recursively calling the function. So that'll be result is equal to self.minimax, and then we're going to be using the player as the human. And then after that, we'll just be updating the score to be whatever score that we determined earlier. So this will be equal to what we find at results at the index of score. If I can type. This also needs to be in quotations. All right. Once that is done, we need to add some else handling statements. So if the player is not the AI, if it's a human, we'll need to be doing a little bit different things. So what we need to be doing is essentially just the opposite. So we'll be recursively calling Minimax for self.ai. And then we'll be doing the same thing with the scoring. All right, I'm gonna run this, just make sure we're not getting any errors so far. Looks like so far so good. So I think we're smooth sailing. All right, so now we've gone through all of that, we need to actually update the board with like our different items. So we will be updating self.board and we'll be just kind of making that equal to a blank space at this particular index, so that we're able to kind of show the entire play of like what the computer is thinking in real time. If you're kind of like making a normal game, you wouldn't have it share the entirety of all the plays, but I want y'all to be able to see this algorithm kind of like in real time, so you're able to understand how Minimax works in real time a little bit better. So after we have that set equal to 0, we're just going to have all of the plays be appended into all of the play and appended into our plays list. So I was able to actually play it later. So after that, we'll go through, and if the player is equal to self.ai, we're going to do a few things to kind of like play out this particular items. So we're going to set the best score equal to is going to be negative float of infinity, and then for each play inside of the plays. So for play and plays. Oh, I hit shift again. Enter. We're going to go through, and if the score of this particular play is greater than that score, we're going to update the score, and the best play will be updated. So essentially, we're making the best score low on purpose so that whenever -1 comes in, if it is the best play, that's what's going to be like added, and 0 and 1 will be updated throughout the course, if that makes sense to y'all. So if play at the index of score is greater than best score, what we're going to do is we're going to change best score at, we're going to change that to play at the index of score. If I can type a quotation, score. And then after that, we're going to change best play is going to be equal to play. I don't know if I declared best play. I think that's why it's yelling at me. I will fix that in a second if that's the case. This is essentially just updating the best play as we go along. And then if play is not better than like this particular one, we're going to kind of like act accordingly. So we will have an else statement here because we don't really want to change anything if the best play is not better. We just kind of want to continue on. So else best score is going to be equal to float of infinity. So this is for the human. This is like the best case scenario for the human. For play and plays. No, I hit shift again. We're going to go through and essentially kind of do the opposite of what we did last time. So I'm going to bring this down. All right, I think that is everything we need for that. And then I'll be returning the best play. So this is going to actually act on the best play it finds. I'm going to run this code once more, make sure we're not getting any preemptive errors. Looks like we're good to go. So we'll keep trucking along with this function. So at this point, we've basically finished the Minimax algorithm. I know that was a lot of stuff, but in a nutshell, it's just going through, it's declaring some scores for the winners. It's going through and it's making kind of an index. It's going through and like making a selection of all the different plays for this item, and it's going to check based on those plays who's the winner. And with those like optimal scores, it's going to determine an optimal best move for the human and best move for the player as well, the AI and the human. So they're able to kind of determine what is the best possible play for the min-max algorithm. All right, so now we need to just kind of work on our play function. Did not add that into the comments, but it's going to be somewhat similar to the play function we used last time, just actually calling the algorithm the min-max algorithm that we used. So we're just going to have play, def play with self, as well as the position. So we know which particular position player's adding in. Then after that, we're going to go through and just kind of like add some similar if statements in order to figure everything out. So, but we are running, I'm seeing pretty tight on time. So I'm going to run through this pretty quickly and then do an explanation after the fact. So if self.board position is in empties. Is that what it's called? Yes. I might want to just shift this around. I might do it hard coded just with how quick we're running on time. Okay, I'm just going to hard code this for the time being. So, all right, so we're going to make this equal to human. And then after that, what we're going to do is run through a few if statements. So we'll do if self dot check winner self human. We're going to then print out that the human is the winner, like so. So print player human wins, and we're going to return true. If that's not the case, we're just going to add another elif statement. So elif not any cells equal to an empty item. So if the winner is not human, and essentially checking that there's like no cells that are empty, and for each cell in like that particular board. All right. And then after that, I'm going to print out that it's a draw. This is me just essentially hard coding in the empties and cat scratch functions for the time being. And we can call those in a little bit. And then otherwise, we're going to have our Minimax algorithm take over. So I'm going to have the AI move is going to be equal to self. We're going to call our Minimax function, and we're going to be using self.ai at our particular index, and we're going to be using updating our board. We're going to be updating that at the index of our AI move to be equal to self.ai, which is, as you see up here, just an X. All right. After we do that, to update the board, we're going to check and see if the winner is AI. So we will do that by just having this. And after we check and see if it's the AI, if that's returning true, then we're going to print out that player self.ai is the winner. But if we're not getting that, we're just going to have it return that it is a draw within this. So I will have this as our elif statement. and we'll actually be calling the functions if we have enough time. I just want to show you like generally how this is working before we run out of time. And then here, towards the end of our object, so outside of the elif, I want to have just a return false statement, similar to the error handling in the other one. What is it upset about here? Expected a colon. There is a colon. We'll run that and see what happens. And then we also need to check for any particular cases where we're getting something that needs a invalid move. So this is going to be all the way out here, and it's going to be else in one. That looks slightly too high, but oh well, we'll see if it is working properly. So I'm just going to have invalid move printing and false, so we end this loop. Right, let's see what's happening. Are there any errors so far? There are. Oh, yes, yes, yes. I need a double equal sign. It's always the little characters. All right, that seems to be running fine. So now I'm just going to quickly instantiate the class. And because we're at 10 minutes, yeah. So in order to instantiate the class, we're just going to have a pretty quick game loop. This is going to go through everything we need. So we'll have while true again. We're just going to have another instantiated game is equal to tic-tac-toe master. So while true, we're going to be doing a few things. We're going to print the current game board. So game dot print board. And then after we do that, what we're going to do is we're going to have the human player's turn, and then we're going to be making the human player's move. So we'll have another human player's move. While true. No, hit shift again. I don't need this extra code block. While true, we're going to go through and try for them to enter their position. So I'm just going to bring in this really quickly for the sake of time. So this is just getting input from our user. Don't know. This is probably just not properly indented enough. There we go. Okay. Yelling at me. Okay. Yeah, because we need the else clauses. Yeah, we're working on it. And then if our position is less than 0, it's going to break. So if our position is going to be less than 0 or greater than 8, or the game board position is empty, we're just going to have it break. So all right. And then here, we're just going to have our else statement that tells them it's an invalid move. And then for our try exceptions, we're just going to have a value error that tells it needs to input a value number if we're not getting a proper return. What is going on? Does not match the previous indent. Okay. There we go. Okay. It's driving me a little nuts. Okay, so now after that, we're going to have the human board or the human player make their move. And we're going to do that just by having game update the position to be equal to game.human. This I don't think is properly indented enough. Yeah, maybe one more tab. There we go. Okay. Then after that, we're going to check if the game is over after a player's move. This is essentially just going to check the winner. And otherwise, it's going to go on and play again. All right. So we'll just have this really quickly, and I will explain to you what it means so we can get through everything before the end. So if the winner is human, player human wins. If not, it's a draw. And we're going to be printing that board after the humans move. And if not, we're going to do the same thing, but for the AI. So we're going to be having the AI's move just be equal to game minimax. So AI move. And after that, we'll just like have the game board be updated and check if the AI is winning. And then that's going to just be equal to gamed AI. And then we'll have the same thing to check if AI is the winner. And then here we have our game. All right, I think I updated everything. Let's play. All right, let's enter our move. Let's play 0. List indices must be integers. Okay, this error again. Line 52. Let's go through. I probably, in my haste, messed something up. For index and self.empties is up here. All right, so for index in for index and self.empties. Oh, I see what I. No, actually, never mind. Play. Oh, I think this is maybe it. It was supposed to be play, not plays, because I'm adding it to that particular play, not the overall array. All right, let's see if this is working now. All right. Name infinity is not defined. Do I need to import? Oh, I also see what the issue is here. Up here, yeah, there needs to be quotes. Play this again. All right. 0. Okay, so as you can see here, the min-max algorithm is working. We are at time, so I will update this in a little bit with some more comments on the slides. But as you can see, I selected for the player, the human, to select 0, and it went through and kind of played everything out using the min-max algorithm to play for both, and it had player X win, so it's choosing all of these different items, which is interesting. So we'll have to go through and kind of see each individual play, but I hope you all enjoyed this stream. I'm going to go back to the slides and quickly show you a few more resources if you want to learn more about game trees and Minimax as an algorithm. You can do so on Free Code Camp. And here is a little bit more about game trees and the math behind Minimax on Wikipedia if you're curious about learning more about the math. If you want to find the slides, you can do so at this bit.ly link, and I'll be updating the code in a GitHub gist at the end of this stream. But if you go to the bit.ly link now and just like refresh the page in a few minutes, the GitHub gist will be refreshed where it says GitHub link on, I think, like slide 5 or 6 or something. Yes, on this, like where it says GitHub link here, there will be a GitHub gist. Thank you all for tuning in and bearing with my few character errors. I hope you all learned something and hope you see around at the rest of game week. Thank y'all. So again, the bit.ly link I'll share in the chat real quick before I pop off because I know that there's another stream coming up in a little bit.